We started a little bit of multiplication back in Objective 3. They were differences of perfect squares, and that meant the two middle terms were going to cancel each other. We continue multiplication in Objective 4, and a lot of times we don't see a difference of perfect squares, such as this one. This is not a difference of perfect squares, and so when I do my multiplication, whether we do it by the FOIL method, if you happen to like FOIL, or if you do it by the matrix method, whichever way you do it, you're actually going to get the two middle terms, the outside and the inside term. So I'm going to do it by the matrix method. 3 plus 2 square root 5, I'm putting that on top. And then 4 minus 7 square root 5. I'll put that down on the side. And remember, all you have to do is multiply to get into each box. So 4 times 3 is 12. 4 times 2 root 5, outside times outside, stays outside. So that would be 8 square root 5. Negative 7 root 5 times 3 is negative 21 square root 3. Sorry, it's square root 5. Negative 21 square root 5. And then the last one, negative 7 square root 5 times 2 square root 5. Well, outside times outside would stay outside, so that would be negative 14. I'm going to do this down here under the box. Negative 7 times 2 is negative 14. Now, inside times inside stays inside, so square root 5 times square root 5 would be the square root of 25. But as you know, the square root of 25 is 5. So if you noticed right off the bat that square root 5 times square root 5 was simply 5, you'd save yourself a step. So the 5 comes out, negative 14 times 5 is negative 70. So those are the 4 terms that we get when we do our matrix multiplication. By the way, those would be the exact same 4 terms if you use the FOIL method. Now it's time to combine like terms. We're going to put the rational part of the answer first. 12 minus 70 is negative 58. And then we're going to combine our like terms right here. Our square root 5s. 8 square root 5 plus negative 21 square root 5 is negative 13 square root 5. And that would be your answer. Now, you might not see both terms like this. You're going to see some problems that are written like this. Now, the one thing you don't want to do, you can't simply distribute the square to both of the terms of the binomial. You just can't do that. You have to actually do what this says to do, which is square the term. Now, squaring the term would mean take 4 plus 3 square root 7 and multiply it by another 4 plus 3 square root 7. Now, I'm going to do this the matrix way again. That happens to be what I'm partial to. 4 plus 3 root 7 on top. And 4 plus 3 root 7 on the side. 4 times 4 is 16. 4 times 3 root 7, outside times outside stays outside, would be 12 square root 7. Okay. Now on this cell right here, it's 3 square root 7 multiplied by 4, which is another 12 square root 7. Now on this one right here, it's actually outside times outside, which stays outside, which is 9, multiplied by the square root of 7 times the square root of 7, which is 7. So 9 times 7 is 63. Now, to write the answer, I'm going to combine the terms that I can combine. So I'm going to take these nice rational numbers right here, 16 plus 63, and that's 79. Now I'm going to add the square root 7s. This 12 square root 7 added to that 12 square root 7 makes 24 square root 7. This next example looks like it's increased in difficulty level because it looks uglier, but actually it's a little easier than the previous one because if you notice, this is a difference of perfect squares. This is 2 root 3 plus root 5. This is 2 root 3 minus root 5. So again, if we remember what happens when we multiply differences of perfect squares, the problem actually cleans up a little bit because certain things go away and they cancel each other. So let's put 2 root 3 plus root 5 on the top, and let's put the other one, 2 root 3 minus root 5, down the side. Now let's multiply these things. What's 2 root 3 times 2 root 3? Well, really what that is 2 times 2 is 4 times 3. So 4 times 3 is 12. Now, if you actually worry about this cell, 2 root 3 times positive 5 is 2 root 15. But if you come down here and you multiply these two things together, what's positive 2 root 3 times negative root 5? Well, a positive times a negative is a negative, so that would be negative 2 root 15. And lo and behold, look what happened. The same thing that always happens when you're dealing with difference of perfect squares. The two middle terms cancel each other. They're gone. Now let's move on to this cell down here. What's positive root 5 times negative root 5? Well, positive times negative is negative, and root 5 times root 5 is simply 5. So, if we simplify this, we always start with our rational terms. 12 plus negative 5 is simply 7. And then we go to our irrational terms, our square roots, and notice they canceled each other out. So there really is only one answer to this problem, and it simplifies down to the number 7. Now, moving on to the next one. Square root 18 plus square root 27 quantity squared. You could work with it like this if you wanted to, but the numbers are going to get pretty ugly pretty fast if you do that. So let's simplify each of these. The square root of 18 can be broken down to 9 times 2. 9 is 3 times 3. So we know this is 3 square root 2. Now 27 is 9 times 3. 9 is 3 times 3. So this is 3 square root 3. But I still have to square it. So it's going to be a little bit easier working with this. I'm going to make my matrix box. I'm going to put 3 square root 2 plus 3 square root 3 on the top. But remember, I'm squaring this, so I'm really multiplying it against itself. So I'm going to put 3 square root 2 plus 3 square root 3 down the side as well. Because remember, if you're wondering why I did this, if I expanded this, this would be 3 square root 2 plus 3 square root 3 multiplied against itself, which is another 3 square root 2 plus 3 square root 3. So 3 square root 2 times 3 square root 2 would be 3 times 3 is 9, and then root 2 times root 2 is simply 2, so that would be 18. Now 3 square root 2 times 3 square root 3, outside times outside stays outside, 9. Inside times inside stays inside, so that 2 times that 3 would be 6. This cell right here is the same multiplication, 3 root 3 times 3 root 2, which is another 9 square root 6. And then this cell right here, outside times outside stays outside, which would be 9. And then inside times inside, root 3 times root 3 is 3, so that would be 27. Now, this makes our final answer 18 plus 27, which is 45, plus 9 root 6 plus another 9 root 6 is 18 root 6. For the last example, we're going to have a binomial on the bottom, and part of that binomial has a square root in it. Now, what a lot of people think they need to do in order to rationalize this, the first thing that comes to a lot of people's minds is all you have to do is multiply by root 3 over root 3, and that'll take care of the problem. Actually, that's wrong. You don't do that. It won't take care of the problem. Let's recreate the problem right here. 8 over 5 plus square root 3. The way you get that radical to go away is you actually have to create a difference of perfect squares. So the way we rationalize this problem is multiplying it by what we call the conjugate, which is 5 minus square root 3. And what that's going to do is when you end up multiplying these two terms on the denominator, since you have now created a difference of perfect squares, the middle term is going to drop out in your answer, and you're just going to be left with two nice rational numbers that you need to simplify. But we're not there yet. For the numerator, we're going to keep it in its factored form. We're just going to say 8 times this is 8 times 5 minus square root 3. Now, the denominator down here is where some magic is going to happen. Look what happens when I take that 5 plus square root 3 and I multiply it by the 5 minus square root 3. We know 5 times 5 is 25. 5 times root 3 is 5 root 3. But 5 times negative root 3 is negative 5 root 3. And then negative root 3 times positive root 3 is simply going to be 3, but it's going to be negative 3 because a negative times a positive is negative. And as you can see, the two middle terms are going to cancel each other because one's positive 5 root 3, the other one's negative 5 root 3. And all I have to do is to reduce this, or to simplify it. 25 minus 3 equals 22. And that's actually what the denominator becomes. So the key to rationalizing this, since it's a binomial term, multiply it by its conjugate, which is whatever binomial is used to make it a difference of perfect squares. And now that I have this problem at this point, I do have a little bit of reducing I can do, and that's why I really didn't multiply these two out, because that 8 and that 22 can both be divided by 2. They can be reduced by 2. That would be a 4, and that would be an 11. And so my final answer in this problem is 4 times 5 minus root 3 all over 11.